Oh, hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Ugobela Mets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 6 still on stoichiometry, quantitative aspects of chemical change. Then 6.1 says potassium permanganate, KMNO4, burns with a bright flame when a few drops of glycerin are added to it. The incomplete equation for the reaction is as follows, and we can see it's incomplete because we are actually not given the chemical formula of the glycerin, and then we also have a missing coefficient here. Then 6.1.1 says define the term molar mass. So let's quickly run to that. So the definition of molar mass, we say this is the mass of 1 mole of a substance measured in grams per mole, right? Then let's move to 6.1.2. It says the composition of glycerin is as follows. It has 39.13% of carbon, 8.7% hydrogen, and 52.17% oxygen. They say determine the empirical formula of glycerin. Show all calculations for 6 marks, right? So we are to determine the empirical formula. Now note that empirical formula is the simplest whole number ratio of all the elements in a compound. So obviously, starting with our step number 1, we have to calculate the number of moles of all the elements, right? So we're going to start by calculating number of moles of carbon. That's basically mass over the molar mass. And then the mass of carbon is, remember, we just take the percentage and convert it to mass. So 39.13 grams over the molar mass of carbon is 12. So when you punch that into your calculator, all you get is 3.26 mole, right? And then number 2, you will have to then do the same thing for the hydrogen. So we have number of moles of hydrogen, it's M over big M, then again 8.7, then over the molar mass is 1. Now you'll have 8.7 mole, right? Then lastly, you're going to do it for the oxygen. So number of moles of oxygen is mass over the molar mass. And then we are given 52.17. And then the molar mass from the periodic table of oxygen is 16, right? Then when you punch that again, you get 3.26 mole, right? Now at this point, step number 2 is to divide by the smallest number of moles, right? So we want to divide by the smallest number of moles. So from this, we can tell that the 3.26 here is the smallest number of moles. So we do that in order to find the ratio. So ratio of carbon is 3.26 divided by 3.26. This will give us 1, right? And then the ratio of hydrogen, it has to be the 8.7 divided by 3.26, which will give us 2.67 if we round off to 2 decimal places. Now, you will need to keep the 2.67 here, and then I'm going to tell you shortly why. Then this is oxygen. This is 3.26 over 3.26. Now, this is just 1. Okay, so we have the 0.67 rule, which says if you have a whole number and then your decimal is 0.67, then in order to convert this whole number here in order to convert the decimal, all of this decimal into a whole number, then you will need to multiply by 3. So the 0.67 rule says every time you must multiply by 3 to get the whole number, right? So whenever you have 0.67, you multiply by 3. It's the same as the one whereby if you have 0.5, you have to multiply by 2, right? So you still remember that one. Whenever you have 0.5, then you need to multiply everything throughout by 2. Now that you have 0.67, you need to multiply everything throughout by 3. Right. So always keep that in mind. So that means at this point, what I will do here is I will then multiply everything here by 3, right? So remember, what I do on this ratio here, I also need to do with the other ratios. So multiply by 3, multiply by 3. Now, if we say 1 multiplied by 3, then our ratio is 3. And then here, 2.67 multiplied by 3, this will give us 8. And then 1 times 3, this will give us 3, right? So that means our empirical formula now is C3H8O3, right? So I know I've been getting a lot of questions regarding this one. So that's the rule that you were supposed to apply here, the 0.67 rule. So which is why from the ratio that you got, you needed to then multiply by 3, right? So you did not have to write this as 3. Remember, we did say that you need to round off to the nearest whole number, but not with the case when you have 0.67. When you have 0.67, then you need to always remember that you need to multiply everything out by 3. The same as you have, if you have 0.5, then you need to understand that you multiply everything throughout by 2, right? So it's also an important rule to note there. So that's how you could have got your 6 marks. So you can play the video as many times as possible and revisit this question here so that you get a better understanding of it. But then let's proceed. Okay, so we have 6.1.3. It says write down the value of X in the equation above if the molecular formula of glycerin is C3H8O3. Right, so let's write the molecular formula here. C3H8O3, right? Now, in order to find the value of X here, we can just try to balance the number of carbon and hydrogens both sides. So we'll say left-hand side, and then here right-hand side. Now, what is the number of carbon atoms on the left-hand side? We can see it's only this 3 here. So if we just put 3 over here, and then on the right-hand side, the number of carbon atoms, we have the 7 multiplied by 1, and then we don't know the number of carbon atoms here as a result of not knowing the coefficient. So we can simply say it's 7 plus X, right? Because to find the total number of carbon atoms on the right-hand side, then it's a matter of adding this 7 with whatever coefficient that we are going to have here. Now let's come to the number of hydrogens. We have 8 hydrogens on the left-hand side, but what's the total number of hydrogens on the right-hand side? That's 16 multiplied by 2, which will give us 32. Now, in order to balance the number of hydrogens both sides, we do understand that it would be just a matter of having to find a number in which we can multiply by 8 so that we get 32. So we can easily get that by saying 32 divided by 8, and then this will give us 4. So now we understand that we now have to multiply by 4 to that 8. Now, how do we do that? We're simply going to put the 4 here as a coefficient. But then note that putting the 4 here as a coefficient now will affect the number of carbon atoms on the left-hand side. So the number of carbon atoms on the left-hand side will now be 3, multiply again by that 4. So at the end of the day, we're going to have 12 carbon atoms. Now remember, this is all a matter of having to balance the carbon atoms in order to find that X. So to find the X here, we can just say if we want to balance the number of carbon atoms on the left-hand side and right-hand side, okay, we can simply say 12 is equals to 7 plus X. Right. Now, to find the value of X is just a matter of saying 12 minus 7, and then our X is going to be 5, right? So the X in here, it's supposed to be 5. And that's it. It was only for 1 mark. So all you were supposed to do is just write 5. But then obviously, there is a process into having to find that, right? So that was the whole process that you needed to do. But then for the 1 mark, you just write 5. Okay, now let's go to 6.1.4. We are given, calculate the mass of Mn2O3 that can be prepared if 18 gram of KMnO4 reacts with excess glycerin. Right, so this is a stoichiometric question, which we now have to understand that we have to follow the stoichiometric steps, right? Note that we are given the mass of KMnO4, and then it's 18 gram. Right. But then we want the mass of Mn2O3. Now understand this about stoichiometry. With stoichiometry, we'll always be given the information of the other substance of which we have to use that substance in order to get the information of what we are looking for, right? So to follow these 3 stoichiometric steps, this is what you do. Number 1, you have to calculate the number of moles of the one in which we are given the mass. So KMNO4. Now, obviously, to calculate the number of moles here, it's just a matter of using the formula N is equals to M over big M, right? So obviously, the mass, we are given 18 grams. Then the molar mass from the periodic table, you will realize that K is 39, and then we have 55, then plus 4 times 60. Now, when you punch all this into your calculator, you're going to have 158 grams per mole, right? So that means here you will have 158. Now, you simply just grab your calculator and then simply punch all of that into your calculator. You have 18 over 158. That's going to give you the number of moles, 0.1139 mole, right? So that's your step number 1. But then step number 2, you now have to use, so step number 2, use the coefficient ratios, right? Use the coefficient ratios. So that means now you realize that what you are actually looking for is the Mn2O3. So that means you will take this molecule here, KMNO4, compare it to the one that you are looking for, Mn2O3. So let's put an arrow on this one to indicate this is the one that we are looking for. Now, what is the ratio? The ratio, remember, you have to go back here and take it from the coefficient, right? So the coefficient here is 14, and then the coefficient for this one is 7. So we have 14 is to 7, which can be simplified because remember, 7 is, we can divide both sides by 7, right? So these two numbers are divisible by 7. So 7 goes how many times into 14? 2 times. 7 goes how many times into 7? Only once. Then the number of moles that we have under KMNO4 is 0.1139. And then we're going to put the X here because that's the number of moles that we are looking for. At this point, we just cross multiply it's 2x, and then it's equals to 0.1139. Then let's divide both sides by 2. So the X that we're going to end up having there is equal to 0.05 696 mole, right? So let's just keep it that way. And then, okay, now that we have the number of moles of the Mn2O3, we can then now calculate the mass, right? So step number 3, we can now calculate. So step 3, calculate the mass of Mn2O3. Now, to calculate the mass, we know that the formula that we have to use is mass is simply equals to the number of moles multiplied by the molar mass. Now, the number of moles, this is the number of moles that we have, right? Just calculated it in step number 2. 0.05696 multiplied by the molar mass of Mn2O3. Again, here, we're going to have, so if we want to calculate the one for Mn2O3, so we have Mn is 55, so that's 55 multiplied by 2 plus 3 multiplied by 16. So this again gives us 158 grams per mole. So we have to multiply by 158. Now, simply take out your calculator and then multiply by that 158. So the answer that you get for this one, the mass is 9 grams, right? The mass is 9 grams. So be careful about this one from your app. I noticed that there was an error on this question. So make sure that when you are practicing using your JSTD app, you pay attention to that, right? So to the error that they made there. So they kind of got 10 point something, but then it's because they used the wrong molar mass for this one here. So the molar mass for the KMNO4 was supposed to be 158. So please note that one. Okay, so done with that question. So you can revisit the question and just try to understand it a bit much more better. So now let's proceed to 6.2. 6.2 says the balanced equation for the reaction of sodium chloride NaCl with sulfuric acid H2SO4 is as follows. Then we can see all that. During a reaction, 1.5 gram of impure, let's note 1.5 gram of an impure sample. Remember, we never get to use this impure sample unless we are now calculating the percentage purity. So this is the one that you read and lock away, right? And then 1.5 gram of an impure sample of sodium chloride reacts with 100 centimeter cube sulfuric acid of concentration 0.1 mole per dm cube. Now, already from seeing the SI unit here, centimeter cube, we know that we have to convert this to dm cube by simply dividing by 1000, right? So the 100 centimeter cube will change to 0.1 dm cube. Always remember that. Now, 6.2.1 says, define the term concentration. What is concentration? So concentration is the amount of substance per dm cube of solution, right? Okay. Now, for 6.2.2, it says calculate the number of moles of sulfuric acid used in the reaction above. Only 3 marks. Now, with 3 mark question, we understand that it's formula, substitution to the formula, and the correct answer. Right, so how can we find the number of moles of the sulfuric acid now that we are only given the volume and the concentration? Okay, so looking at that, we can see that this corresponds to the formula C is equals to N over V. If we have concentration and volume, then the number of moles can simply be found by using that equation, right, or that formula. So the concentration is 0.1, and then we have number of moles. The volume, remember, divided by 1000, we also get 0.1. Now, when we cross multiply here, that's 0.01 mole, right? Okay, so 3 marks for that. Formula, substitution, and the correct answer. And then let's now proceed to the one here. On completion of the reaction, it is found that 460 centimeter cube, again, centimeter cube, we must divide by 1000, right? Now, this will give us 0.46 dm cube. So immediately you see that you just convert. Of HCl gas has formed. Calculate the percentage purity of the sodium chloride. Use 24.45 dm cube as the molar gas volume, Vm at room temperature. Now remember, I said when they mention molar gas volume and then you also see room temperature, the formula that you must always have to put in your mind is the STP formula, which goes N is equals to V over Vm. Now looking at this molecules here, we can see that the only gas molecule that we have is the hydrochloric acid. And this formula here only works for gases at room temperature. Right. So again, with this question here, we're going to follow the stoichiometric steps. Again, let's go through those steps. So step number 1 is to do what? Calculate the number of moles. Calculate the number of moles. This time the number of moles of what? Of HCl. Remember, what we are trying to get to is the percentage purity of the sodium chloride. But then we know we cannot just go directly to that sodium chloride. Stoichiometry works in a way that you will have to first solve this and then use the ratio to get to that. And then at the end of the day, you can now solve for the required value. Right. So to calculate now the number of moles, we have to use the formula N is equals to V over Vm. The volume that we are given is 0.46. And then the Vm, 24.45 dm cube. This is the molar gas volume. They even indicated Vm. So we want to substitute it here, 24.45. So we are given the volume of that substance and also the molar gas volume. Now, when you punch that into your calculator, you get 0.01881 mole. Right. Then step number 2 now, you have to then do what? Use the ratio coefficients, right? So use ratio coefficients. Why are we using ratio coefficients? Because now we want to move from hydrochloric acid to sodium chloride, which is the one that we are looking for. So we'll say, what is the ratio of HCl to the ratio of NaCl? And then from looking at here, we can see that the coefficients are 2:2. So a ratio of 2:2 can be simplified to 1:1. But then a ratio of 1:1 means that they will have the same number of moles. So if the number of moles of hydrochloric acid is 0.01881, a ratio of 1:1 means that the number of moles of sodium chloride also again has to be 0.01881 mole, right? So this is the number of moles that we have for sodium chloride now. Okay, then step number 3, we'll now have to calculate for the required value. So in this point is to calculate. Remember, the percentage purity is calculated by mass. So calculate the mass of sodium chloride. So that would be your step number 3. Now, to calculate the mass, there we go now. So we know that mass is equals to the number of moles multiplied by the molar mass. The number of moles we already have 0.01881, then multiplied by the molar mass of sodium chloride. From your periodic table, if you just add the sodium molar mass and then the chlorine molar mass, you are supposed to have 58.5. Then your mass, the mass of sodium chloride, when you multiply that, is supposed to give you 1.1 gram. Right. But then are we done? No. Remember, we still need to calculate the percentage purity. Right. So again here, allow me to just have this little compartment here. Okay, then to calculate the percentage purity, we know that percentage purity is mass of pure over mass of impure, then multiply by 100, right? So that means the mass of the pure is the one that we just calculated, 1.1. So this is the one that reacted. Remember, the mass that will react is the mass of the impure. Then 1.1 over 1.5, which is the impure, as we are told here, 1.5 gram of impure sample, then multiply by 100. Then having to calculate that, you just simply take out your calculator, then it's going to be 73.37%, right? So that's how you were supposed to calculate that for a total of 6 marks as well. So we were loaded with those 6 marks questions there that you needed to understand a bit much better, right? So, okay, that's it for the lesson today. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.